Hi friends, welcome to follow up. Let's have a look at problem 905, sort array by parity. So this is a daily challenge problem, and in this video we're going to analyze this problem in some detail, right? So here we are given an array, right? We want to move all the even integers as beginning of the array, followed by all the odd integers. So we want to return any array that satisfies this condition. Actually, it's this requirement that makes this problem actually very straightforward. So here I'm going to first digest this problem using some brute force solution, and then we want to slightly improve. So here, for example, this problem, so we have 3, 1, 2, 4. So as long as the 2 and 4 are in front of 3 and 1, that will be okay. So like this output are all acceptable, right? So here in the second example, we just have an even number, so it just return the list itself. And also in this problem, the length of this array is not that long, so it's bounded above by 5,000. So with that said, we are ready to do the analysis. So here, what we want to practice. So we want to go from simpler or straightforward one to some slightly complex one, right? So here first, we can do sort, right? So we can sort. So when we do sort, we can use the sort key to be their remainder, right? So we can use a sort key. So using a specified key function, right? So for example, we can use given an element, so we can consider its the result modulo 2, right? So the smaller will be in front, but the even has remainder 0, right? Odd will have remainder 1. So this is the one. Or we can just pick out the even numbers and odd numbers respectively, and then we put the even numbers in front and followed by the odd numbers. That's also good. So here the last one maybe we consider is that we want to notice that so as long as the even numbers come before odd numbers, all odd numbers, that will be fun, right? So this actually can enable us to use swaps. We can do this swaps, so we can realize this by just a simple two-pointer method. So let's look at each of them. So for the first one, so we can do a sort. So here I change this to capital A, so just for convenience you can remain nonce. So here we can do sort in place, right? So the key will be something, let me use a lambda function. So given the representation of the element in the list, so I'm going to compute its remainder modulo 2. So in this case, so the even number will have remainder 0, and odd number will have remainder 1. Therefore, the odd number will come after even number. So in this case, we can directly return this A. So now let's do a test. Yeah, in this case, it gives 2, 4, 3, 1, right? Yeah, it passes the test. So this is one solution. Let me copy this part. Change this to be V1. And now let's look at the second one. So here, in the first solution, we do the operations we sort in place. So here, for the second one, we can pick out all even numbers, and then we can pick up all odd numbers. So in this case, so we can see even numbers. So it's just say x for x in A if x modulo 2 equals 0, right? So then we can copy this line and change this to be odd numbers. Odd numbers for those elements in this list A such that its remainder over 2 is 1. So in this case, we just need to return even numbers plus odd numbers, right? So this is corresponding. This corresponds to the second second idea. Pick out the even numbers and odd numbers respectively and connect them. So we saw this works, and now let's look at the generic case. Yeah, it passes all the case. So here, as for format, so for this one, you can use one pass, right? So in this case, due to the list comprehension, we check the list for twice. So this is 2 pass. So you can use one pass, right? So what do we do? So we can use this one, initialize it as empty. Similarly here, and then we do linear scan. So for x in A, right? So if x modulo 2 is 0, so in this case, we're going to do even numbers append this x. Otherwise, so we're going to do odd numbers append. So this way, we just use one pass. Then we do the return in the same fashion. So now let's look at the test. Yeah, it passes all the cases. So this two, basically, we use a sort in place, and then we use 2 pass or 1 pass list comprehension, or just a for loop. So now let's copy this function signature, and we want to use a 2-pointer method to address this problem. So here, actually, the reason we can use 2 pointers to do swap is due to the assumption that, or the requirement, we can return any array that satisfies this condition. So now here, let's first get the length of this list, and then we are going to initialize 2 pointers. So ij equals 0 and the end index. Then basically we want to check the elements parity at indices I and j, right? So if I is even and j is odd, so we continue. So we increment I and decrement j. So this is one case. Another case, if I is odd and j is odd, we are going to increment I. And then if I and j are both corresponding to even elements, so we are going to so in this case we are going to increment I only. And another case is I corresponding to an odd number and j corresponding to a odd number, so we are going to decrement j. So now let's write the solution. So well, I less than j. So because if I equals j, so we don't need to do anything, right? So if ai modulo 2 is 0, it's already even, and a and j modulo 2 is 1, it's already odd. So in this case, we do I and j equals I plus 1, j minus 1. So this is one case. So let's just write this 4 conditions. So actually this can be simplified. So another case, if ai modulo 2 is even and aj modulo 2 is also even. So in this case, we have already set this one, and then we're going to increment I by 1, right? So this is the one case. Another case, if ai modulo 2 is 0 and aj modulo 2 is 1. So in this case, we just need to decrement j, right? So now another case, if ai modulo 2 is odd, right, and aj modulo 2 is even, right? So in this case, so we want to switch, but we cannot switch ij because in this case, yeah, let's see, because this is an 0 1 0 0 0, so here it should be 1, right? 4 possibilities. So in this case, aj is already odd, we can remain it fixed, so we decrement j by 1. So now let me check that. So here we have AI as even, right? And AG is odd. So we cannot switch IG. So we want to do let's see. Let's see. This already in place. Yeah. So yeah, this is right. So now let's look at the solution after we do. And then if it's not right, so we can carefully check this. Oh, sorry. So here is IG, I plus 1 G. Yes, let's see. So let's maybe write a simplified version. So once we have this, if they are in correct place, the I corresponding to even number, the G corresponding to odd number. So we do this. And the other case, if AI is even, so we want to increment I, right? So this, no matter what, we should do this. If AG modulo 2 is 1, so no matter what, we want to decrement that. So this, I guess, covers all the cases. So now let's do a test. I guess we didn't do the swap. So here we do AI AG equals AG AI. So that's an important one. So now let's do a test. Oh, here. So I guess I need to change this to be view 2 and with 3, and then this will be checked, right? Now let's test this one, IG. So here, let's see, if AI, so here, yeah, so this will be, if this will be 1, and this will be 0, so we do swap. Now let's do the test. Yeah, it passes the case. So notice that this is different from the expected one, but it's a valid one. So now let's do a final check. Yeah, it passes all the cases. So let me recap this one. So we can use 2 pointers. So the first case is that if the first corresponding to an odd number and the G corresponding to an even number, we need to swap them, and then we increment I and decrement G. So in any case, if AI is already even, so we should increment I. If AG is already odd, so we're going to decrement G, right? So with that said, I guess that's about it for this video and for this analysis. Thank you.